In this section, what we're going to start seeing is that polynomials sometimes have a certain structure, and these structures that we might see here are perfect square and difference of two squares. So what we're going to start with, let's start with the perfect square. We've heard about this before. Doing vertex form, you have to have a perfect square. Notice this looks like the first part of vertex form. What do I mean by vertex form? If you have like x minus 2 squared plus 3, notice that, this is vertex form, but this part's the perfect square, which is why we complete the square to get vertex form. So enough of vertex form, because that's not really what we're doing here. We're just factoring in this section. So we're just going to focus on what is a perfect square. So if we look at like x plus 1 squared, this is a perfect square. It's x plus 1 times x plus 1 if you expand it out. And let's go ahead and just FOIL it. So you would get x squared plus 2x plus 1 if you FOIL it. If you have, let's just say x plus 3 squared, then that's x plus 3 times x plus 3. And if you FOIL that, you'll get x squared. Now I'm going to go ahead and actually FOIL it out this time. Plus 3x plus 3x plus 9. I just want you to notice something, that these are both the same numbers that we get there, or both the same terms that we get there. So 3x plus 3x is 6x. So it just doubles that number if you think about that. That's important to realize that it's just doubling it. It's just doubling the 3. Right? Because you're just going to do x times 3 is 3x, 3 times x is 3x, add them together, it's just doubling it, and then 3 times 3 is just squaring it. So it kind of takes a certain form, and what I'm getting at is this formula right here. Notice we're just doubling it, 2 times the a times b, plus b squared, and then obviously x squared. So we can kind of see that form already taking place. What if it's a minus sign, like x minus 4 squared? Then you have x minus 4 times x minus 4, and we can already assume that it's going to be, x squared, and then minus 8x. It's going to be double that, but I'm just going to show you why, because minus 4x plus 16, negative 4 squared is 16. Notice this number is always positive with a perfect square. And so that's x squared minus 8x, just like we assumed, it's double that number, plus 16, which is negative 4 squared. So it takes this form right here. A squared plus 2ab plus b squared. It's just taking this first one and squaring it, and then adding it to 2 times those two multiplied together, and then adding that to this term squared. Or if it's a minus, these just end up being negative, and we can see why right here, because you have negative 4x minus 4x. Now let's look at, let me just put a note right here. So this is for perfect squares. Drag it down real quick. And now let's take a look at difference of two squares. Has a longer title, but it's honestly easier. It's called difference of two squares because look, it ends up being a squared minus b squared. A is squared, and then b squared, that's also squared. It's a difference because it's subtracting, so it's a difference of two squares. That's where the name comes from. So let's look at the factored form of it, because we're going to be going backwards in a little bit. So if you have the difference of two squares, what you're going to have is, let's just say x plus 2, x minus 2. Notice the difference of two squares. These are both the same factors except for one thing. It's the opposite on the middle there in the operation. So they're both 2's, they're both x's, but it's a plus here, a minus there. So what happens, we get x squared if we FOIL it, and then minus 2x plus 2x minus 4. So when you FOIL that out, the negative 2x plus 2x just cancel out and leave us with x squared minus 4. So it's really cool how that works out. This can do with like so many other numbers. X plus, let's go with 9, x minus 9. Then you get x squared minus 9x plus 9x minus 81. And that's, just notice there, the 9x and the 9x cancel out. We have x squared minus 81. Let's take a look at x plus pi, or let me do x minus pi. It ends up being the same thing. So x minus pi, that's a number. And then x plus pi, you would get x squared plus pi x minus pi x, and then minus pi squared. And then pi x minus pi x just cancels out, leaving us with x squared minus pi squared. And there you go. You can see that the result of this ends up being the difference of two squares. So if you identify that you have two squares being subtracted from each other, you could easily factor it back to here. Notice there's a plus on one, a minus on the other. It's the square root of this one there, and the square root of that one is the number that goes there. And that's how we could go backwards from there. Just like we're going to look at the perfect squares and figure out how we can go backwards using that same pattern.